In this video, we are going to look at how to determine or calculate for internal forces, that is the shear force and the bending moments, when we have a simply supported beam that has point load. And the guiding question says a beam ACDB 6 meters in length is simply supported at A and B and carries a load of 300 newtons at 2 meters from support B as shown below. We are required to calculate the internal forces, that is the shear force, bending moment, and actual forces at point C and D. This is the simply supported beam, and we can see this is a roller support. This is a pin, can be taken to be a pin jointed support, and this is a beam that has a point load 300 newtons at 2 meters from support B. Now let us look at the solution to this particular problem. The information provided to us is that we have a simply supported beam that has a point load of 300 newtons and it is at 2 meters from point B. Now, after looking at that problem, the loading conditions of the beam, we can draw what we call a free body diagram to help us analyze the external forces that are acting on that particular beam. So, of course, before we calculate for the internal forces, we must find the values of the external forces that, of course, result into the generation of the internal forces. So the external forces, since we have a roller support here, it will have only one reaction vertically upwards. Then where we have a pin jointed support, we will have two reactions, one in the X direction and another one in the Y direction. Then we have the point load F 300 newtons at 2 meters from support B. Now when we consider equilibrium conditions, we know that first of all, sum of horizontal forces must equal to 0 for a system to be in equilibrium. The sum of horizontal forces must equal to 0. Now, of course, we are considering the positive X direction forces to be positive. Since we have B acting in the negative X direction, then that minus Bx will equal to 0, and that means that Bx is equal to 0. We move ahead, we consider another equilibrium condition that says sum of vertical forces, considering the positive Y direction forces to be positive, then their sum should equal to 0. And this is the condition number 2. So if we look at that equation or that condition, it means vertical forces must reduce to 0. In other words, they should be balancing, which means that the upward forces should be equal to downward forces. We have upward forces as AY and another one being BY, so AY plus BY should be equal to 300, which is the vertically downward force. Now, after stating that, we also know, of course, we have one equation, so we need, of course, one equation with two unknowns. Therefore, we need to find another equation that can help us solve one unknown and then come and substitute in here to find another unknown. And the next equilibrium condition is the sum of moments. So if we are taking moments about B, since we know that B will have more than one reactions, and therefore taking moments about here is convenient because it neglects all the reactions at this particular support. Therefore, we are saying sum of moments is equal to 0, taking the clockwise moments to be positive. Then it means that negative 300 is going to have an anti-clockwise moment. Therefore, negative 300 times 2 plus, of course, AY is going to have a clockwise moment. So it will be AY, the perpendicular distance from the line of action of AY is 6. Therefore, we will have that third equation. And when we carry out the algebra, we find that 6ay is equal to 600. So divide both sides by 6. Divide both sides by 6. This one will cancel out, and here we will have 100. 100 newtons. So ay will be 100. So meaning that from equation 2 we can substitute for ay and calculate by. So this will be 300 minus 100, and this is going to equal to 200. So by is equal to 200 newtons, and we can go ahead and put these values in the free body diagram. So we see ay is 100 newtons, by is 200 newtons, acting at 2 meters. Ay at 100 newtons at 2 meters from C and at 4 meters from D. Then we also know that from this support we have 200 newtons reaction, but with also another vertical downward force acting at D. So we are required to calculate the internal forces, that is the bending moment, shear force, and axial force at point C and at point D. So let us make a cut at point C, and the free body diagram of segment 1, when we consider the left hand side, then it will be having normal forces NC, that is the axial force, then the shear force. If we make it vertically downwards, it means the moment, the bending moment that counteracts this shear force is going to be in an anti-clockwise direction. Likewise, if we consider now the next section, for example, if we consider it, then the shear force would be facing vertically upwards, then the bending moment would be facing in a clockwise direction, because the clockwise moment here and this one here must always cancel each other. Then the shear force here and the shear force on the right hand side of the section should also reduce to 0. So if this force is acting at 2 meters from the section that has been made by cutting, then we can also use equilibrium conditions to calculate the axial force. Then since it is in a horizontal direction, then sum of forces in the horizontal direction should give us 0. So since the only forces acting is NC, so negative NC, since it is pointing in the negative x direction, negative NC is equal to 0 and NC is equal to 0. Now let us calculate for the shear force VC at point C. So since it is a vertical force, then sum of the vertical forces, considering this free body diagram, the sum of vertical forces should be equal to 0. Now when we consider this free body diagram of the segment, we see that 100 newtons is pointing in the upward direction, and the VC is pointing in the vertically downward direction. Therefore it will be negative. So we will have 100 minus VC equal to 0, and VC is going to equal to 100 newtons. Now we move ahead and calculate for the bending moment at C. So the sum of moments, again, that is another equilibrium condition that is being applied to the free body diagram of this sectioned part, or this segment of the beam. So sum of the moments is equal to 0, considering clockwise moments to be positive. So MC is pointing in the negative direction, that is the anti-clockwise direction, and 100 is pointing in the clockwise direction. The perpendicular distance from the line of action of 100 newtons is 2 meters from point C. Therefore we will have the sum of those moments, considering the free body diagram above, it will be minus MC plus 100 times 2, and this will equal to 0. Therefore, the bending moment at that point C is going to be 200 Newton meter. So that is how we can calculate the internal forces, the shear force, the bending moment, and the actual forces at point C, going step by step. Now let us look at the internal forces at D, and we shall also make a cut at point D, and then have a free body diagram, then take equilibrium conditions, and be at the end of the day we will be able to find the shear force, the normal force, and the bending moment at point D. So summing of forces in the x direction gives us the normal force ND to be 0, and we proceed and sum forces in the y direction, considering the positive y direction forces to be positive. Then we will have 100 is pointing in the positive y direction, then 300, of course, if you consider this cut, then you'll have a cut that is slightly passing, that is slightly beyond D, but at a distance that is so negligible that we can consider to be 0. Therefore, that force 300 is going to be considered in this free body diagram when we consider a section cut at point D. So forces pointing downwards, we have VD and 300. So it will give us VD equals 300 minus 100, and therefore the shear force at that point D is going to be 200. Likewise, if we need the bending moment, we need to take moments about point D, and considering clockwise moments to be positive, then if we sum these moments should be equal to 0, then we look at the bending moment is pointing in the negative direction, that is the anti-clockwise direction. Then the 300 is also pointing in an anti-clockwise direction, basing on taking moments at point D, and since it is a negligible distance, then it is going to be 300 times 0, then plus, of course, this force which is having a clockwise moment. Therefore, it will be 100 times 4, because its perpendicular distance from point D is 4. Therefore, I will have MD equivalent to 400 newtons. So this is how we can calculate the normal forces. We have the bending moment at D, we have the shear force at D, and we have the normal force at D. Thank you so much for watching. See us in the next video.